everyone. So in our previous lecture we have seen how you can graph the linear inequalities. Now today I come up with the special cases of graphing the linear inequalities. Here I have mentioned the two examples. In both of these examples, whether we have the y only in the equation or the x only in the inequality, not the equation, it's the inequality. So we'll start with the example number 1 where we have the y is less than 2. I have already told you that it is not necessary that you should have equality sign in the linear inequality. It can be without the equality sign, just like this example. So whenever we plot such inequality, we have to plot first the equation with the equality sign, like plot y is equals to 2. So in such a case, one thing that you have to keep in your mind is that while plotting, don't keep the line as solid line. So its line will be dotted because there is no equality sign in the question. I am just assuming this in order to find out the area that will be covered in this given inequality. So if I start with plotting y is equals to 2, it means that the value of y will remain 2 for any value of x. It means if I draw here the line, this is the 2 and I'll draw the line like this. This whole line is representing y is equals to 2 on any value of x. So this is how we have to draw the line of y is equals to 2 in case of this is y is equals to 2. But we have not plotted a solid line because in the solution set, or you can say in the solution of this solution set means what are the values that will be included while graphing this inequality. So the values that lie on this red dotted line, that is y is equals to 2, will not be included in the solution set of inequality y less than 2. Now the next step is we have to shade the area that will be included in the solution set of y less than 2. So as it is less than 2, as I have told you in the previous lecture, that when it's greater than, then you have to take the area above the line. But here we have less than 2, it means the area below the line will be included. So if I shade that area, it will be like this. This area will be the solution set of given inequality. So I can say that it will represent y less than 2. So all the values that lie below this dotted red line will be the solution set of, or you can say that will be the graphical solution of the given inequality y less than 2. Now let's move towards the next example where we have the equation x greater than and equal to 2. Now here we have the equality sign. It means we have to plot x is equals to 2 first, but with the solid line. So keep this in mind that here we were having the dotted line because this line was not included in the solution set. While in this case, we will have a solid line because it will be included in the solution set of the given inequality x greater than and equal to 2. So x is equals to 2 will be, what does it mean by x is equals to 2? It means the value of x will remain 2 for any value of y. So this line is representing, so this solid line, so this solid red line is representing x is equals to 2. But our linear inequality is the x greater than and equal to 2. It means the solution of this inequality will be the points included in this solid line as well as the points above this line. So it means the solution set will be this area, including this solid line, because there was an equality in the given inequality. There was an equality sign as well. So this area is representing the x greater than and equal to 2. It means 2 will be included as well as the value of the x that is greater than 2 will be included. So this is how you will plot the linear inequalities. These are the special cases that you came across. So you keep this in mind, the difference between them regarding the dotted line and solid line. It means in dotted line y is equals to 2 will not be included, but in solid line x is equals to 2 will be included. So It means dotted line is showing exclusion and the solid line is showing inclusion of the given point. So that's all from today's lecture.